I hope that it works. I think I should select the right window. And hope it is the right one, because one never knows. Let us hope it is working. I'm not that sure. Well, it could be, or it could not be. Let us try. If I'm showing you this PowerPoint presentation, or this one here, I would work. Yes, please, I would not be in a, I'm there, but somewhere so you can hear my voice. So calculating phase diagrams sections of iron alloys. We've been working today in the classroom, working with some specific binary iron alloys with the variable composition. So this is lecture I've been using for the master course, which is running on Fridays in this period. In this is a presentation using, of course, Pandat in open databases as well. And it has been done some, I think, 1 month ago. And it includes a basic digression, which is my own, I'm a boomer, understanding of chat GPT. Then everyone is talking a lot, but I will try to do my own presentation. So, which is the point? I would like to have a look what is possible to get from a practical equation for the liquidus temperature of iron-carbon binary system under high pressures. Of course, I should compare the results using computational metallurgy, Halford, and the software and a database for what it is possible to get, or it was possible to get something like 1 month ago. These are some 7 questions, and maybe this is already a weak point. Find 20 relevant scientific works to calculate an equation for liquidus temperature of iron-carbon alloys, including effects of pressure, based on Kalfa thermodynamic databases. And then all the questions similar you can read here. And just checking because I think I don't remember everything that I've been asking to this ChatGPT application. So this is the window. It was, yes, 1 month and 10 days ago. Today is the 1st of March. Well, propose an equation for liquidus temperature of iron-carbon alloys, including effects on pressure. Well, the response is pretty reasonable. I mean, gets a constant, something depending on carbon content, and something depending on pressure. That's a good starting point. So calculate an equation for the liquidus temperature of iron carbon, blah, blah. Without additional information, this is also reasonable as well. So I've been working a little bit out, nothing special because the paper is over there. And if you can get it from your own e-library, you can get this paper, which is dating back some 9 years ago. Then there is a database included in the paper, and you can download it and open it. You can open, I am interested in it. This is temperature in Kelvin, but we will modify it likely. This is iron content. This is just a curve that I've been obtaining using the command phase projections. Phase projection is over there. You can, once you have the database, you can do your own without troubles. Well, then my question was more specific. You can use this paper and you can increase your knowledge. And that's the point. The response is not so different, but because it uses not a linearization, but something with a linear regression using several variables and their combination. So carbon content, pressure, and then polynomial expression. And then this is something more critical. I should check it, but probably, and this is the point that we have seen, that not all the papers that are quoted here could be real. We should check ourselves using Scopus, Google Scholar, whatever, to check if the response is a real one or it is a good approximation, but it is not the right answer. So this is the tentative syllabus we've been discussing in the first lecture. And then again, I underlined that please find the time to listen to Professor Harry Badesha's story, which is very inspiring, really. And I mean, he has his YouTube channel. You can find much more information than this simple course there. And I think it is worth totally to listen to some of, I don't know how many, hundreds or thousands of videos are there, but you can find them, and I strongly recommend this. You can just go on YouTube and listen to 1, 2, 3, 10, whatever you would like to listen to. I underlined that Professor Badesha was so kind last year. He's been recording for us for University of Udine an entire course on steels. We start here with Martenside, and it is an advanced course, but it is from a very wise person and kind person as well. So it is totally worth it to listen to it when you have time. Take your time and listen and what's going on. If you have the possibility to get the books, better would be in paper form. But if you prefer to get them, for instance, from my own university library, you should be a student of university, and this is a good choice. And you get Theory of Transformation in Steels from an ebook and also in paper version. I'm actually having it, so it is not available because I'm using it. And also the Steels, it is in an ebook form. You can download it. In this book, Steels, Microstructure and Properties by Professor Badesha, you will find in page 3 a phase diagram for pure iron in the alpha, gamma, and epsilon form. We are used to standard pressure, so not kilobars, just standard atmospheric pressure, 1 bar. But increasing the pressure will make happen several transformations. So in metallurgy, we are not used a lot in using high pressures, apart it could be from some application in cold or hot isostatic pressing, but I mean, it's not so strong a pressure that you can find for some geophysical applications. And this is why I've been using a paper from Earth and Planetary Science Letters by those two colleagues, Eli Brosh and Yang Fei. And this is some supplementary material that you can download and you can open with Pandat without troubles. You should not change anything. You can use the thermodynamic database as well, provided there, and it works. You can download it from there. So this is the thermodynamic database opened in Pandat. It's not always clear, but it's not important for you. So what it is important for students that we can select pressures and using just one composition, that of iron, produce those graphs. You can browse because I will also insert the PowerPoint presentation that I'm using now. So you can select it and you can produce your own graph, which is not too bad if you compare this one, the book or presentation, and this is the picture. Unfortunately, is not so good, but this is FCC, BCC, and HEP, ACP, sorry. Sometimes I'm switching to Italian. And so epsilon for HEP, ACP again, alpha there, and gamma. Quite good. This is for iron, pure iron, and this is for iron, carbon, and pressure. Different effect for 5 giga, 10 gigapascal, 20 gigapascals. And this is figure 2 of the paper. And it seems that for 20 gigapascal, the result is good enough, even though we don't have a liquid plus diamond here, probably because I have moved the diamond phase out of the possible phases included in the database, but I should check. Yeah, now it's better. Mhm. This is possibly how it works to view conditions. And so you can view conditions and see what's going on. So this is the standard batch file for Pandat. It starts with those headers. And it is typically something with the XML format as well, with some indication. This is, you can see more clearly, and even more clearly you will see in the PowerPoint file. 10 gigas seems pretty reasonable. 5 gigapascal, yeah. Something good, but some differences over there and over there. This is nothing which we should use. Those are the phases that are inserted. And again, this is the encoding. These are details you can browse directly in the PowerPoint file. And it is the game or including or not included the diamond A4 phase. Well, there are more complex iron carbide than FC, Fe3C, which is cementite. You can have several iron carbides. I recommend to have a look at this open paper, which has some 7 years, but I think this is the best one for considering some iron carbides and their possible detection by using the Mössbauer spectroscopy, which is a quite specialized uh, technique, analytical technique. I wouldn't go that long for an introductory course. You can select those different values, and again, these are the tables you can get from Pandat, and this is something you can build out even from Excel. Okay, for the moment, recommending you to consider not only the presentation by Professor Badesha himself, but in his own channel, you can listen to this presentation, which I like because it is a very nice presentation of all the topics related to chemical metallurgy and thinking them in a green way. So this is totally worth to listen this presentation, and also it is totally worth to listen to the presentation by Professor Bo Soonman, which is over there, and you can download his own software from OpenCalfat. For the moment, that's all. Just switching back to recommended that you can download in Italian or in English those 3 books on steels, which is very useful for engineers, not only mechanical engineers. Blah, 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 blah. And for the moment, that's all. Okay, so I should stop. You should see my face somewhere. And then I should try to switch off. I should try to switch off a recording of this lecture and see what's going on. Mm.